flow fields are these cool looking patterns that you get when you simulate the movement of points over some noise. And in particular, this noise is called Perlin noise. And Perlin noise, as you can see, is not just a random value per pixel. Instead, the random value of each pixel is dependent on the random value of each other pixel. And in Blender, the noise texture node actually uses this exact same technique. So that's exactly what we are going to use in this tutorial. And the first thing that we're going to do is creating a flow field in 2D on a plane like this. And later I will show you how to add a flow field on any 3D mesh. But let's get started with this plane. So let's click on the plane and click on new to create a new geometry node. And let's call this 2D flow field or something like that. And the first thing that we want to do is not simulating this plane. Of course, we want to simulate points that are added on top of this plane. So let's do a distribute points on faces node, and then we get a bunch of points. And these points, we want to simulate them. And in order to simulate them, we are going to need a simulation zone. So let's connect that all like this. And now to actually move the points, we are going to need a set position node. And then if you change the X offset, for example, to 0.1, then you will see the points start moving. However, we don't want to move the points just like this. We want that the movement of the points is dependent on some noise field. So what we're going to do is a noise texture node, and this noise texture node is going to control the offset of the set position. And then if you press play, you will see they all go into oblivion and they go very fast. So let's first fix that it goes very fast. Let's slow them down a bit. We're going to do that with a vector math node, which we set on scale, and then we can scale down the strength of the noise texture to like 0.1 or something like that. And then you will see if you press play, they go a lot slower, which is perfect. However, they still go diagonally up. And the reason for this is because this noise texture now has a range from 0 to 1. So when we move something with this noise texture, it will move away from the 0 point. And that's not what we want. We want that it moves around the 0 point. So we're going to make the range minus 0.5 to 0.5. So if we do another vector math node, which we set on subtract, we can simply subtract 0.5 on each axis. Let's see what that looks like. Yes, that looks quite good. Then we also see that the points are not staying in 2D. They are also going on the Z-axis. And at the moment, we do not want that. So let's remove the Z-axis from the simulation by doing another vector math node, which we set on multiply, and then multiply the Y-axis and the X-axis by 1 and the Z-axis by 0 so that it's excluded. And then you will see it actually stays in 2D, which is perfect. And this setup already works. It's fine. However, I want to do this a little bit different. I don't want to connect these 4 nodes directly with the set position. No, what I want to do instead is create an attribute, a velocity attribute for each of these points. And later in the tutorial, you will really see why we should do that. So if we do a store named attribute node and we set this on a vector, we can name this velocity or something like that, and then connect the scaling with the velocity. And now we can disconnect the scale from the set position. And then to make it move again, of course, we want to do a named attribute node so that we can call the velocity attribute. And then if we connect that with the set position, now we have our effect back. Okay, so now we have this, and yeah, this looks a little bit boring. And the reason why it looks boring is because we're only using one set of points. We're only using the points that are added in at the first frame of our simulation. And what we actually want is that we add in more and more and more and more and more points each frame of the simulation. And to do this, we're going to do a join geometry. And then if you put the distribute points on faces with the join geometry, now we will add in more and more and more points each frame of the simulation. However, you see it's making streaks, and at the moment that's not really what we want. And the reason that this is happening is because the seed of the distribute points on faces is always 0. So the way the points are distributed is the same on each frame, and then you're getting no randomization at all. So let's do a scene time node, and if we connect it with frame, now the seed changes each frame of the simulation. And now if you press play, then you will see you're already getting something that looks like a flow field. Oh, and by the way, let's in the noise texture, let's change the detail all the way to 0. And let's make the scaling 3 or something like that. And then you will see you're getting something that is more fluent like. Alright, that already looks quite cool. However, let's now make it that we're removing points if they are too far out of the grid. And to do this, we need to calculate the distance from each point to the original grid. And for that, we have a very simple node. So if we do a geometry proximity node, and as the geometry, we do the original grid geometry, and then we have the distance from each point to the grid. And we can say with a compare node, we can say, okay, if the distance is greater than 0.1, for example, then we should delete it. And we're going to delete it with a delete geometry node. So then we can say, connect this one with the selection, and then you will see points are getting deleted. Okay, for the next part, I'm actually going to turn off the join geometry for now, so that we only see the first set of points. Because the next thing that we want to do is make it that when a point moves, that it leaves like a streak of points, which we can convert into a line, so to say, so that each point is kind of drawing in line. And to do this, we're going to need a second geometry socket in our simulation zone. So if you press N to get this sidebar, you can go under node, and then under simulation state, you can click on plus, so that we have a new geometry socket, and then you can rename this to joint points or something like that. And the joint points, we need to connect it like this so that we're cycling through the simulation. And each frame we want to add the output of this socket to the join geometry socket. So if we do another join geometry nodes and we connect it like this, and then we connect the joint points with the group output, then you will see each point is making streaks, and that's perfect. And these streaks of points, we want to convert those into curves. So if we do a point to curves node right over there, then you see that doesn't really look good, right? And the reason that it does this is that the points to curves node is now trying to connect every single point with each other. However, we want that it only connects these points with each other or these points with each other. And we're going to do that by using the curve group ID socket over here. Because if we look, for example, at these points, each of these points has the same exact ID, and also each of these points has the same exact ID. And that's perfect because if we make use of an ID node, which contains the ID of each point, of course, we can connect it with the curve group ID. And then if you press play, you see that already looks like a cool flow field kind of thing, especially if we turn on the join geometries again, of course. And then if you press play, yes, we're getting a cool looking result. So if you press play, you see that already looks quite cool. And I completely understand if you are thinking, okay, done, completely fine. However, there's more that we can do to this. So for example, we can make this look more like a river flowing, so to say. And to do this, as you can see, the end parts of each curves are never getting removed. So this point, for example, or this point, it's never getting removed. And if we remove those points after some time, we're getting a river-like animation. So to do this, we need to have the age of each point that we're adding in over here. And to get the age of those points, we're going to do a store named attribute node, which we set on integer because the age is an integer. It's just 1, 2, 3, 4, 5. And then as the name, we set age. Okay, the age should go up by 1 each iteration of the simulation. So if we do a named attribute node, which we set on age, and this is an integer, we can connect it like this. And then if we do a math node, which we keep on add, and we add 1 each iteration of the age. And now with a delete geometry nodes and also a compare node and this named attribute, we can say, okay, if the age is greater than 30, for example, delete the points. And then if you press play, you see it looks like the streaks are flowing through the flow field. And that looks quite cool. Of course, you can choose for it to not do this. However, I do recommend to do this so that you can save some computer power. Otherwise, we're going to work with a lot of geometry. However, these nodes, we can also do that for the original geometry. So the points that we're adding in at the beginning of the curve, so that the curve at some point stops generating. So let's take these nodes, shift D them to there, connect them like this and like that, and then name this HOG so that we are getting the age of the original points. And then let's also take these nodes, shift D them to over there, and then connect them like this and like that. Let's make some space, and like this and like this and like this. And the only thing we need to do now is make this HOG. And now if we press play, you will see it is like this. And now we are working a little bit efficient with our computer power. And of course, the higher you set this number to like 60 or something like that, and this one also to 60, then we will see we're getting more and more and more stuff. Another way, of course, to get more streaks is by setting the density higher. So let's do 60, for example. And then you're already getting this, which looks quite amazing too. However, I can completely understand that after all these minutes of doing this specific tutorial, that you're thinking, oh my god, what is all of this? I have no idea what I'm looking at. How am I ever going to learn this? I wish there was just some way in which I can just learn every single note in geometry notes in a very easy and clear way. Well, then I have good news for you, because I created the Big Notebook. It's a book that explains over the course of more than 200 pages every single note in geometry notes. And the good thing is that it starts from the very basics and slowly progresses towards more advanced techniques. The book is available on my Gumroad, and if you use the code FIELD, you will get 25% off of your purchase. So if you want to boost your knowledge in geometry notes, I recommend getting this book today. And with that being said, let's continue the tutorial. Now we have this. And this is already quite cool. However, these are just still curves. And if we would go into render view for this, we wouldn't see anything because curves are not rendered out. So we're going to convert these curves into a mesh. And we're going to do this with a curve to mesh node. And as the profile curve, normally I would say we're going to use a curved circle for that to create some thickness around the curve. However, we are working with so much geometry over here that we want to minimize the number of vertices as much as possible. So in this case, we are just going to use a curve line node. And if you connect that with the profile curve, then you see, yeah, that doesn't really look good. The reason why this doesn't look good is because we don't want to use the z-axis for this. So let's do 0 on the z-axis and 1 on the x-axis. And then you see, okay, that still doesn't really look good. And the reason for that is that 1 is way too big. So let's set this on 0.01. And then you see we're getting a very cool looking flow field. However, there is one extra thing that I want to do, which is that you see that each curve, the thickness of each curve is always the same throughout the entire curve. And it would be more beautiful if the end parts of the curves are very thin and the middle part of the curve is a bit thicker. And to do this, we are first going to set the x-axis on 1. That's a little bit easier. And then we're going to add in a set curve radius node. So like this, and now we have this radius socket, and this radius socket, we want that to be dependent on a spline parameter node. So if you connect the vector, then you will see, okay, that is not good. And the reason for this is that the vector goes from 0 to 1 throughout the curve. However, 0 to 1 is way too big. So let's remap this with a map range node. And this is saying, okay, at the moment it goes from 0 to 1, but make this go from 0 to 0.0001 or something like that. And then you see that looks quite good. However, you see, if you take a look at this curve, for example, it goes thin and it goes thicker, but it doesn't become thin again. And that's logical because we're not saying that it should do that. But if we want that, then we should do a float curve node. And at the moment, the beginning is 0 and the end is 1. But we want that both ends is 0 and then that the middle part is 1. And then you will see it's thin, thicker, thin, which is perfect. And maybe we can make this even thinner to like 0.0001, for example. Yes, that looks good, especially when we're going to do texturing. Talking about texturing, let's do that now. So before we're going to do anything with the texturing, let's actually go into render view mode. So let's switch the render engine from Eevee to Cycles, and let's set device on GPU compute if you have a graphics card, of course. So if we go into render view mode, then we see we have this. For the cool effect, let's actually set in the world properties the color on white. And then if we go into the shader editor and we open up a new material, we can name this black for now. And then if we make the base color all the way to black, we see nothing is happening. That's because, as always, we have to assign this material in geometry nodes. So let's do a set material node right over there, and let's connect black with it. And then you see you're already getting a quite cool effect. And by the way, if you put the color on white and you look at the white color over here, you see it isn't really pure white. And the reason for this has to do with the color management of Blender. So if you want to have pure pure white and pure black, you can go over here into the render properties, go into color management, and as the view transform, set it from AGX to standard. And then you're getting those pure black and white values. And with this effect, I think it looks pretty cool. But later, if you're going to make a whole scene, for example, I do recommend to set it back on AGX. However, I think we can make a material that is a bit more colorful. And to do this, we're going to make the background completely black. So let's do color black over here. And then we're not going to use the principal BSTF. We are going to use an emission node right over there. And the cool thing is we can make this color value dependent on the velocity that each point has. So if we do an attribute node, you remember that we created an attribute called velocity. And now it's really handy because this velocity value, we can use this in the shader editor. So if we type over here velocity, then we can connect, for example, vector, and then you will see you're getting nothing. Okay, for the last 20 minutes or something like that, I was a little bit stressing because I couldn't get any results with this. But when I was practicing this tutorial, it was working perfectly fine, and now it's not. However, I found a solution, and for some reason, if we call this attribute here velocity, it doesn't work. But we can call it, for example, everywhere velocity 1, and here velocity 1, and here velocity 1, then we're getting some result in this. And okay, so what I wanted to tell you was that if we connect vector to color, then we're seeing the vector direction of each point. And also this vector contains the speed of each point. And the speed of each point is very cool to visualize. And we can visualize this with a vector math node, which we set on length. And then we're getting the length of each direction. And the longer it is, the faster it goes. And then you're getting this result. And this length, it's very cool to make this control a hue saturation value node. So if you set it on hue and then set the color on red, for example, then you see you're getting just this, and you would think, okay, but it's just blue. What is so special about this? Well, the cool thing is if we do a math node, which we set on multiply, and we multiply this by 2, for example, then you see we're kind of getting different kind of colors over the flow field. And if you put this multiply node higher, then you see you're getting it even stronger. However, I will keep it on 2 for now. And if you want to cycle through the wheel of colors, then you can do another math node, which we keep on add. And now if you just add colors, you see you can cycle through the colors. However, let's preview it like this. Yeah, then you see you get something like this. But I think a lower value for the multiply node will look a little bit better. Let's see. Oh yes, this green one I really like. And off screen, I actually accidentally put the T2 max value a little bit higher. So let's set this back on 0.001. And then we can put the emission higher to like 3. And then you see we're getting a cool result, maybe a bit higher. Yes, that's really cool. And again, the more you simulate, the more points are going to be added in and the cooler this is going to look. However, at the moment, we only have it in 2D. And I told you that we're going to do this in 3D. So let's add in a complex 3D mesh. And we're going to use the legendary Suzanne model for this. So if we move that a little bit over here, let's add in a subdivision surface modifier for this thing like this. Let's set the subdivision of 2 and let's do shade smooth. Okay, let's do add modifier, geometry nodes, and let's add in the 2D flow field on Suzanne. However, in this case, we want to make it a 3D flow field. So let's click on this 2 to create a duplication of this geometry nodes. And then let's name this 3D flow field. Okay, let's see. Let's press play and let's see what is happening. Okay, we are not seeing anything. Let's turn off the curve to mesh for now so that we can see what is happening. And let's also turn off this join geometry so that we're just having these curves. So we see that the curves are only going in the X and Y direction and not up and down, for example. And in this case, we actually do want them to go up and down. So we can actually remove this multiply node by pressing Ctrl X. And then you will see it is already better. However, they are now going everywhere. And actually to visualize this a little bit better, let's make it that we also see the Suzanne model. So let's do the group input over here and also a join geometry. geometry and let's connect that like this. Okay, we see that the points are not really flowing over the surface of the model. And the reason for that is because at the moment we just say, okay, the points should follow this noise texture, and this noise texture is in 3D, so it goes in all directions. However, what we kind of want to do is that when it moves a step on the noise texture, it should after that also snap to the closest face of Suzanne, so that it always stays on it. And to snap it to the closest face, we're going to make a little bit more space over there and over there. Okay, and then we want to do another set position node after the set position of the velocity. And let's move this over there. And then let's also do another geometry proximity node. However, we do want to keep the connection. So let's do Ctrl-Shift-D to duplicate it and keep the connection. Now, if you put the position of the geometry proximity into the position of the set position, you will see that it always snaps to the closest face of Suzanne, and that already looks quite cool. However, you see that it's also clipping through the mesh, and that's not good. So let's make it that it's a little bit floating above the mesh. So we need to have the normal direction of each closest face. So to find out what is the closest face from each point to Suzanne, we can do a sample index node. And as the geometry, we do the group input again. So let's do that like this. And as the index, we want to have the index of the closest face. So let's do a sample nearest node. And then we have the index of the closest face. And let's make a joint over here, shift right click and connect it like that. However, at the moment we are getting the closest point of the mesh, we want to get the closest face of the mesh. And the information that we want to transfer from mesh to point is the normal direction of each face. And this normal, as you can see, is a vector. So let's connect that like this. And now we want to add the closest normal to the closest position. So let's do a vector math node, which we keep on add, and let's add the normal to this. And then you will see it is not looking good. And that's because this normal direction is way too strong. So let's do a vector math node, which we set on scale, and let's scale this down by 0.05 or something like that. And then we see, okay, it can be even lower. So let's set this on 0.01, for example. Yeah, that looks good. You could even make it lower, like 0.005. Let's see. Yes, that looks quite cool. And then you see it works quite well, and it works even better if we turn on the joint geometry again. So if we turn that on, then you will see it looks very cool and it works in a perfect way on any 3D mesh. Let's see what it looked like in render view mode. So let's turn on the curve to mesh again, and let's go into render view mode, and then you will see, oh, let me remove my light. Yes, then you see, whoa, that looks quite cool, to be honest. Oh, and by the way, 3 small things. If you want that the flow field is not going just randomly like this, but that it goes in a certain direction, then you can do that by going into this subtract node over here. And if you make the subtract node, for example, on the x-axis 0.3, then it goes more towards the x-axis. And the lower you set this, the stronger it becomes, as you can see. Same for the y-axis. So if you put the y-axis like this, then you see it goes like that. Okay, that's cool. Let me set this back on 0.5. And also, if you want to get a different variation of noise, then you can set this noise texture from 3D to 4D, and then just change this W value to any number that you like. And then you will see you're getting a different variation of noise. And then lastly, if you don't want to simulate this, but you just want to have a static flow field, just like the one that I had in this shot of the introduction video, then you can do this entire tutorial in the same way. However, use a repeat zone then instead of a simulation zone. And then also make sure to count the number of iterations so that you can use that as the seed of the distribute points on faces. And that already brings us to the end of this tutorial. I think this tutorial was a little bit less complicated than tutorials that I had in the past. However, I do think that the results are very cool or even cooler. So I hope you liked this video, and if you did, please give this video a thumbs up, comment down below if you have any questions, and if you don't want to miss out on any future videos, I recommend subscribing to the channel. And with that being said, check out the big notebook and use the code FIELD to get 25% off of your purchase, and I see you in the next one.